In this video, I'll show you how to analyze the performance of a BLDC motor using Ansys Maxwell. First, open the Ansys software. In the top left corner, you will be having the file option in the menu. Just click the file, click open examples, double click RM Expert, double click BLDC. There will be so many BLDC machine models. Choose the model WS1. Just copy it, Ctrl C. Paste it in a folder in the D drive. Go to the D drive. Create a new folder. Maybe it is lab. Inside the new folder, paste it. Now close this. Come to this, open the software once again. File, open. The computer, open the D drive where you have stored this WS1. We have stored it in the lab folder. So lab WS1, open. Now we expand this project tree. WS1 is the model of a brushless permanent magnet DC motor. Expand this project tree like this. Expand the machine. Expand stator. Expand rotor. Expand analysis. And expand definitions. Expand materials. Completely expand the project tree like this. Now double click machine 1. See, this window will be opened. Here you will have the details like number of poles, then position of the rotor, whether rotor is inside or rotor is outside, then what is the frictional loss, what is the windage loss, what is the rated speed, what is the DC supply or AC supply which you are going to give, and stator winding, whether it is star connected or delta connected. Here it is Y3, means it is 3-phase star connected. If you have designed a BLDC motor newly, then you can change all these data according to your design. Now we are not going to change anything. We are just going to keep the data, keep the same data which is given in the demo model. So just click OK. Then double click stator. So the outer diameter of the stator, inner diameter of the stator, the length of the stator, the iron stacking factor, and what steel type you are using for the stator, how many slots are in the stator, and what is the type of slot, skew width. All these details you have to give. Type of the slot, if you double click here, there are a different type of slots. One, this is the second type slot, this is the third type slot, this is the fourth type slot. So let us choose slot type 2, which is already given like that. Just click OK. Then next click slot. So we have chosen slot type 2. So all the different dimensions of the slot height, slot width, etc. should be fed here. So you can see the diagram of the slot, what is HS0, what is HS1, what is BS0, the opening here, what is BS1, it is the width here, BS2 is the width here. All these dimensions you have to give here. Next is the winding. So there are different types of windings. You can see winding, 2-layer winding we are going to use, and winding type may be whole coiled, half coiled, etc. Or you can use a user defined winding also you can use. How many parallel paths are there in each winding? how many conductors per slot you are going to place, what is the coil pitch, number of strands, wire size, etc. you have to give here. Next come to the rotor. For rotor also you have to give the outer diameter, the inner diameter, length of the rotor, steel type, iron stacking factor, and pole type. Pole type, there are pole may be arranged on the rotor in different ways. This is the second type, this is the third type, this is the fourth type, and this is the fifth type. So we are going to use type 1. Click OK. And next for the shaft, the shaft is made of magnetic material. Just click OK. So after feeding in all the details, next go to this setup 1. Under analysis you have got setup 1. So here you have to give the setup at which in which you are going to analyze the motor performance. So it is going to operate as a motor under constant power load. What is the rated output of the motor, what is the rated voltage of the motor, what is the rated speed, what is the operating temperature, all this data you have to give. After that, go to in the menu, go to RM expert, validation check. So you are checking whether your model is okay. If your model dimensions are correct, then you will get a green tick here, then close it. Suppose by mistake if you give the rotor diameter greater than the stator diameter, then the model will not be validated. So there are some mistakes in the design, the model will not be validated. And after validating, you just again click RM expert and click this analyze all. So the analysis is done. Here in the messages you will have a display WS1 D drive in the lab folder. Just expand it. You will get the message normal completion of simulation on server on local machine. So your performance analysis simulation is completed. Now you have to view the results. So you can right click this setup 1. You will have a performance design sheet, curve, etc. So if you open this performance, if you click this performance, you will get all the finite element analysis input data which the machine has used for analysis. Next one is the design sheet. In this you will have the complete design data, what is the rated output power, voltage, number of poles, given rated speed, the stator data, stator slot data, what is the type of the coils, and what is the complete data about the rotor, the data about the permanent magnet, what is the material used, what are the steady state parameters, the no load magnetic data, full load data. Full load data is generated after the analysis is done. So all these data will be displayed here. Next curves, you can get the performance graphs. See here you have got the different in this drop down, you will have the different curves. It is input current versus speed, or efficiency versus speed, output power versus speed, output torque versus speed, cogging torque, the air gap flux density. We have seen this in the class yesterday. The air gap flux density will be a square wave distribution. The induced winding voltages, you can also see the winding currents under load. all these graphs you can see. See, in this RM expert, in the results, go to create RM expert report rectangular plot. You will get this window. Here you can have this x-axis as speed, and you can get all the graphs in a single sheet. See, here you have chosen current, input DC current. Click on new report. You will get the graph like this. Percentage, you can click on percentage. Percentage means it is efficiency. If you give add trace, in the same graph efficiency will be added. If you give on output power, add trace, in the same graph output power will be added. Torque, add trace, in the same graph torque is added. So you can get all the graphs in a single sheet. You can also edit these graphs. You can click it if you want dotted lines or solid lines or line width, anything you want to change, you can do it here. All these x-axis, y-axis labels, all these also you can edit. You can also save these graphs. You can copy image or export or import. You can save this image.